Welcome one and all to this third episode of D and Other D with me, Mike, and...
Lilith.
Yeah, me, Lilith, that was. A little bit of a shy one, but that's okay. And today we're going to keep on working on this sliding tile puzzle game. So where we left off is we've got the picture correctly split into parts, right? And we need to deal with a few things. One thing would be scramble the picture, which I think should be our next task. And then, if we have enough time, we're going to deal with selection and swapping, right?
Mm-hmm.
Okay, so let's begin with scrambling the picture. Now, I've already done quite a lot of this code by myself to try and figure out how to do it. And I've figured it out. Actually, let me hit play here. Let me hit the space key and pause. All right, so let's look at the situation. The problem is these are all... canvas elements, and you'll see that if you try to move them, you can't. They go back. And the reason why they go back is because of the horizontal layout group and the vertical layout group here. So these control the position of all of these objects. So we can't just move them around. Okay? We are going to have to sort of teleport them around. Okay?
Okay.
And to teleport them, we're going to have to like move them in places. For example, I'm going to have to take, say, this one, and I'm going to have to put it here. And then this one, I'm going to have to put it here. See? And now I swapped them.
Yep, I see.
I swapped a few of them. So it's a bit messed up. And that's actually, it looks like I swapped loads. Oh yeah, that makes sense because I've put the one that's supposed to be here, I probably put it here, so it shifted these forward, but this one then went there. Yeah, that makes sense. So that's the kind of thing we need to worry about. So it's not that simple. All right. Now,
All right.
all of the things that I have done, I have marked with daddy. So you see this one says daddy cell, and then this is your original cell. And then there's the game manager, and the game manager has lots of daddy stuff, which is all here and here. Okay. Now, we're going to begin by building the scrambling system. Okay.
Okay.
Let's see if there was anything important here. I don't think so. Don't think so. Okay. Here. Good. So what we're gonna do here is we're gonna create something to scramble them. So you're gonna say void void scramble cells with a capital S.
Wait, don't I need to go back to a space?
No, you're fine. Scramble cells with a capital C. Open, close round, open a squiggle, hit enter twice, close it, save. Alright, so here when we set up our UI, the cells are all placed. We can remove all of the daddy stuff here. Save. Actually, yeah, save. And this is a good place to call scramble cells. So go scramble, should immediately appear. There it is. Open, close round, semicolon. Semicolon. Save. Control S. Yeah. Now, your cell, in order for us to move it about, we need to know its position. So what we're going to do is we're going to save the X and the Y, okay? So here you're going to create a public. Now space. Call this one vector2int. There it is. So what a vector2int is basically two pieces of information, an X and a Y. That's it. Okay? So you can call this one correct box, no spaces, capital B, box position, capital P. Semicolon. And then we're going to create another one, copy it all, paste it, Instead of correct, you're going to put current. C-U, so just U. Oh, we already have the C. U-R-R-E-N-T. Save. So correct means the one where the box is supposed to be, right? And current means the one we're in right now. So when we initially build the box, right? We already put it in the correct position, remember? Because the picture is already correctly sorted.
Yep.
So then we need to scramble it. Now, we should actually request here, when we set up the cell, that it gives us the coordinates as well. So request vector to int. So just type vector to int. There it is. Space, and call this one position with the lowercase p. Save. Okay. And here we're gonna say copy this, correct box position, paste it here, equals, and copy position, paste it here, and semicolon. Save. So that's to know our correct position. And now for the current position, copy here, paste here. We don't know it yet, so we're going to say equals new, N-E-W, space, space, vector to int, hit tab, open a round bracket, and we're gonna give it -1 and -1 again. Save. Now, our coordinates, right, when we put the picture together, start from 0, 0. Remember? 0, 0 is the bottom left picture. As you go to the right, what goes up? X or Y?
X.
That's right. So it goes 0, 1, 2, 3, etc. Right? And when you go up, what goes up?
Y.
So you get 2 of these numbers, right? Say, for example, 0, 0 is the bottom left. If we cut it in 4 slices, both vertically and horizontally, the maximum is 3, 3. Right? So, for now, -1, -1 means we haven't given you a coordinate yet. That's what we're going to do. Okay? So now, you see setup cell is unhappy because it needs the coordinate. And the coordinate is going to be new. So type new. Space. Tab. Open around. And now you say box X. There it is. And box Y. And there it is. And now we close it. Save. Cool. Now we have these. In order to scramble the cells, we are going to have to do something a bit more complicated. We can't just go random. And the reason why we can't just go random is because we want this. We don't want a single one of the cells to be in its correct position already. Okay? So all of them must be in a wrong position. Okay? Which is pretty important.
Okay.
And none of them can be in a position where another one already is. Right? You can't have 2 cells on top of one another. Aha! So that's going to require some thinking. Okay?
Okay.
So, to do that, what I think we're going to use is we're going to use dynamic lists. Okay? So, you're going to create in here, you're going to type list. That. Hit tab. Open an of type bracket, which is this. Okay? And here you're going to type cell, capital C. Close of type. There. Okay, and call this one list underscore, which is shift minus. Yeah, and call this one scrambled cells.
Or is it capital C?
Oh, it's fine. Lowercase s is fine. Your sister uses capital. I use lowercase. Scrambled cells, no capital C. Cells, space, equals, space, new, and EW space.
EW.
No, you already did it. Space, tab. Open, close round, semicolon. Save. So this has built a new list that will contain all of our scrambled cells. Then we're going to copy all of this, paste it over here, and call this unscrambled cells. So put a UN right here. Save. Now, both of these lists are empty, but the unscrambled cells technically should contain every cell, right? Because at the beginning all of them are unscrambled. So let's copy cells and put it in here. Save. Okay, so now all of your cells are going to be present in the unscrambled cells list. Okay, so now we're gonna do a while loop. So you know how we've done for loops before, right? We've done for loops before. Actually, do we need a while loop? I can't remember. What did I do? Let me check here. Yeah, I did do a while. I thought so. Okay, never mind. Right, now I forgot something actually. We're also going to need a list of available positions. So let's create another list. But this one is going to be vector2. Or open of type. No, shift this. Yeah, and vector2 int. There it is. Close of type. Space. List underscore. Available positions. Close. Positions. Capital P. Yeah, equals space new space tab open close round semicolon save. Okay, so here we're gonna do a while loop. Now do you remember how for loops work? You go for I equals 0 I.
Yeah, first there's a 0, then 1, then 2, then 3.
That's right.
then
It keeps on going, but by a number, right? A while loop doesn't go by number. A while loop goes as long as something is true. So type while, W-H-I-L-E. There it is. It's already there. Open around, and here you need to give it a condition, and the condition is going to be copy list of unscrambled cells, paste it here, dot count. Is higher than 0. So as long as this list has at least one object in it, at least one element in it, one cell, then we need to keep repeating this. This means inside this loop you're going to have to remove them from here. Okay?
Okay.
So that's the first step. Now we need to get the list of available positions built in here. Okay, so the first thing we're going to do is we're going to clear the list. So copy this, paste it here, dot clear. This empties the list. Like that. Okay?
Okay.
Then we're going to have to add all of the positions that exist into the list. So we're going to say for, actually wait, we're going to copy these. We're lazy. We're going to copy this, copy. Paste it here. Copy this. Paste it here. Close, close. And here you can do Shift Tab a couple times. There we go. All right, so if you remember this is how we built all of our cells, going by Y and then by X. It's exactly the same thing. This will give us all of the coordinates that exist. So we can say, copy this, paste it here, dot add, open round, new, space, tab, open round. It's gonna be copy box X, pasta, comma, copy box Y, pasta, close round twice, semicolon, save. So the first step is adding every single coordinate that exists on our board. So it will be 0, 0, 1, 0, 2, 0, 3, 0, 0, 3, excuse me, 0, 1, 1, 1, 2, 1, 3, 1, 2, 0, 2, 1, etc. That's how it goes. Well, vice versa. Anyway, but that's how it keeps on adding stuff, okay? So we're gonna have all 16 of our possible positions stored here. Now remember what we said though. We said we cannot have any available position that a scrambled cell already has. Right? So if a scrambled cell has already occupied that position, we need to leave it alone. So yeah. So now we need to remove all of those. So you're gonna hit 4. Tab, hit tab twice. That 4, yeah. Now copy list scramble cells. Paste it here. Dot count. So we're gonna go through the list of done. Save. We're gonna go through the list of scrambled cells, all of them, and all of them we're gonna remove from the available positions. So here we're gonna say if. Actually, no if. We will know that this exists. So copy list available positions. Paste it here. Yeah. Dot remove. There it is, remove. Now open round and we're gonna remove list scrambled cells, so copy. Paste it here. Number I, whichever one it happens to be. Semicolon. Oh, my bad, I forgot we need to, it's the current box position. There we go, save. So we're gonna remove all of the box positions of the scrambled cells. Now we're gonna be left with only the available positions. Okay?
Okay.
Okay. And now that we have all of this, we are going to move the position 0 of the unscrambled cells into the scrambled cells and give it a certain position that we want. Now let me think how we do that. We would want a certain random position of our choice, and that's okay. Does it matter to us which one? Let me see. So if the random position is different from the current position of that particular cell. Yes. Okay, so here you can say if open round, and we're gonna say this one, copy, paste, square bracket, now type random, this one, dot, don't type anything, range, this one, open round. So do you remember how random range works?
No.
It chooses a random number between a number and another number. So here we're looking for one of the available positions. Suppose the list has 5 available positions. This means it's going to have 0, 1, 2, 3, and 4. See? That's 5. 0, 1, 2, 3, and 4. 5. So we need to choose a random number between 0 and 4. Now 4 is one less right, then the count of available positions, then the amount of available positions. So copy this, and here we type between 0 and, now paste it, dot count. And the reason why we don't have to do -1 is because this is an exclusive range. See, and it says minimum and maximum inclusive. That's for float. Let's close it, and probably it'll give us the int now. Yes, see, return a random integer number between minimum inclusive and maximum exclusive. This means that the maximum will never be there. It will always be one less than the maximum. So now we chose a random position among the available ones. Now we need to check if the list of available positions, actually, do we? Right, we need to check if the list of available positions is not, okay, no, wait a moment, I think I'm getting confused. So I don't think we need to check anything with the random position, because the random position will always not be taken. So all we gotta do is give it to them. Ah, right, here's what we need to check. We need to check that it's not the same one as the one we already have as our correct position. Okay, so if list position is not the position of the unscrambled cell, copy this one, paste it here, 0 dot correct box position. So as long as the position we're picking is not the same as our correct one, because otherwise we're not scrambling it, right? We're leaving it in the correct place. We don't want that. So as long as it's not the same as the correct one, then we finally know we have a valid position that we have picked, and we can give it to the unscrambled cell. The problem is we actually need to store it. So here you're gonna type, we're gonna copy this, copy vector to int, paste it, and here say random position. Save. Copy random position, paste it here, equals, cut all of this, paste it here, semicolon. Now copy this random position, paste it here, save. All right. So if random position is not that, finally we can put the cell over there. Now we should probably have a way to move it. So there needs to be a public void in the cell. So go public void, space void, space move cell, capital M. Open round, and it's going to copy all of this, paste it here, and it requires a position. Save. And we're going to say copy current box position, paste it, equals copy position, paste it, semicolon, save. Okay, so we're going to move the cell. So we're going to say this. Copy list scramble cells, paste it, say dot add, open round, and we're going to add this one. Copy this, paste it here, close the round, semicolon. So we've added it to the list of scrambled ones. Now we need to remove it from the list of unscrambled ones. Well, we're going to do something else first. So copy this, paste it here, dot move, which is the one we just created. There it is, move cell. Open round, and you're going to give it the random position. So copy this, paste it here, close round, close round, semicolon, shift 0. Semicolon. Okay, and now we need to remove it from the unscrambled cell. So copy, pasta dot remove at. There it is, 2 down and then tab with the arrows. Down, down, and then tab. Tab. Open round. Now this one wants an index. Now we've taken 0, so we're gonna use 0 again. 0. Close round.
Oops, that's O.
That is O. Close round, semicolon. Alright, so let's go through this all over again. Number 1, we delete the amount of all of the available positions. Number 2, we add all of the positions that exist on the board to the available positions. Number 3, we remove all of the positions that already are taken by the scrambled cells. Number 4, so that will leave us with a certain amount. Suppose that initially we had 16. After we scramble the cells, one of them, well, after we scramble the first cell, one of them will have a current coordinate, and we remove that one as an available one. So our available positions will not be 16 anymore, will be 15. Then we're gonna pick a random one of them, whichever, doesn't matter. Then, only if the random position is different from the correct position of the cell we're looking at, only if that's true, then we do this. If it's not true, we're gonna skip and gonna repeat the entire loop once more. Okay? So only if it's not true, let me think for a second here. There's a risk actually. We may get an infinite loop, I think. Is it possible to get... No, we won't get an infinite loop because it's always an even amount of cells.
What is an infinite loop? One that goes on forever?
Yes. Does it? It wouldn't technically need to be an even amount. No. If it's an odd amount, well, I mean, we should never make an odd amount. Something important to keep in mind. Anyway, so step 4 I said was create this random position, find it, and then if the random position is not the correct one, then we can say, okay, we scrambled this one, and this same one we're going to move it to the position we've said, and we're going to remove it from the list of unscrambled ones. So this should give us all of them scrambled. All right?
All right.
So eventually, right, all of this will be done, like the entire loop and everything. And now, once all of this has been done, we're going to have to update the UI. So make it so that all of the cells go in the right positions. So we're going to create a void here. Yeah, void, space, update UI with a capital U. Update UI. Update UI, capital U, capital I. Close, open, close rounds, open a squiggly. Enter twice, close it. Save. Okay, so when we update the UI, we need to worry about parenting. It's not about moving these cells around, it's about deciding who is going to be their parent. So we have the rows somewhere. Oh, there they are. The rows, these are our main parents. These are for the Y axis. And the X. And the X will decide which order things go in. So the first step, we're going to put all of the correct cells in the correct Y rows, okay? So we're going to say for FOR and hit tab. And cells.length .length. There it is. Hit tab. So we're going to go through all of the cells. And we're going to say cells I square bracket I dot transform, so T, there it is, transform, dot set parent. There we go. We're gonna change our daddy, our parent, okay, for this cell, and it will depend on, well, first of all, we choose the rows. So copy rows, paste it. Now square bracket will be copy cells, I, paste it, dot and it's current position dot y, right? So we're gonna go into the correct y row, but it's still not happy because the row is a game object, not a transform. So dot transform. Close. So remember how we don't have them here, but remember how in our puzzle image, right, there are rows and then inside it there are cells, and each row has 4 cells. If we scramble them, we need to move some of the cells in different parents, different rows. That's what we're doing now. So here we've moved all of the cells into their correct rows. They're still not correct on the X. That's something we still need to do. Now to do that, we're going to go through the rows and through the columns. So again, we're going to copy this particular loop here. So copy all of this, paste it here, paste it. But we're going to make a change here. Instead of making a loop that goes forwards, we're going to make a loop that goes backwards for the X. And the reason is...
like 5, 4, 3,
that's right.
1, 0.
That's right. And the reason is, I'll explain it to you. We don't have that much freedom in terms of who we put as a child of what parent, in what order. The order is very important. Okay?
Okay.
So we're gonna go wait a moment. Yeah, like this. So let's think of our board here, right? So we split it in 4 like that, right? And then 4 over here, right? This is our board, correct?
Yep.
And now we've put them all in the correct... Actually, I've not split it enough apparently. Have I deleted this one by mistake? Doesn't matter. So here, right, we have ourselves this situation. Now, suppose we've ordered them all correctly by row, but we could have a situation like this. 2, 0, 3, 1. 1, 2, 0, 3. 3, 2, 1, 0, and 0, 1, well, 2, I guess, 3, 1. So we could have something crazy like this, right? And these all need to be reordered, so they're gonna be 0, 1, 2, 3, right? Okay, so if we're going backwards, you can take the third one and put it first. Then we take the second one, put it first. Because we put it first again, it's gonna go before the third one. So look at this. You put the third one first, it goes here, right? Then you put the second one first, it goes first, and it moves the third one forward. Then you put the number 1 first, and then the number 0 1 first. See? Mm-hmm. Now I have 0, 1, 2, 3. Okay? So that's kind of the logic by which we're gonna go. But I just remembered that we need to first order them. So we're gonna have to get an ordered list. I don't think there's gonna be any other possibility. I think. So it's going to be... Wait. Let me think for a moment. If I put them in order, do I need to? Well, I need a method to get a cell from a coordinate, I think. Don't I? Yeah. Okay. Create a non-void this one. You want a cell. Capital C, but that's okay, got it. So in here you want to type it capital G get cell from coordinate or position, put a capital position. So this means this function is going to need a position. So vector to int. Okay. Position. You type position. Okay, close round, open squiggle, hit enter twice, close it. Save. right? So we will want a cell from a position. So we're going to have to go through all of those cells and find if it's the right position. So here you're going to go 4 and then tab, 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 and cells.length. Actually, look, it's here. Copy it, paste. And here you can say if open round cells I square bracket I dot current position, there it is, current box position, equals copy position,
What does
paste.
the equals mean?
It means it's the same as. So if the current position of the cell is the same as the one we're requesting, then it means we found the cell that we're looking for. That's the cell we want. So you can return, here type return. This means give back. Okay, return space and copy cells I, paste it here, semicolon, and here at the end, in case everything goes wrong, type return so if we couldn't find the cell, return null, which means nothing. Save. Okay.
But don't we need them to return to their spaces at the end?
You're not, what you're saying doesn't make any sense. There's a difference between the human language return and computers returning. So this function here, meaning when you call get cell from position, you see it's not a void, it's a cell. So it needs to give you back some information. That's what return means. It's going to give you back this information over here. Or it's going to give you nothing if you get it, if it cannot find it, which should never happen. But look, if you turn this off, the computer is going to go like, hey, your function doesn't always return something. Not all code paths return a value, so it doesn't accept it. So we need to tell it, okay, if everything fails, then return nothing, okay?
Okay.
So now we can get the cell from position, and we can tell it where to go. So we're going to say, copy this, paste it here, and now we're going to feed it a new space, tab, vector to int, open round, box X, copy this, paste it here, and box Y, copy this, paste it here, close, dot. So now we have a cell, transform, dot, set parent, set as first sibling, which means first child. Save. Now there's a problem. We're going in the right order. Is this going to work? I think so. So 0, 0, current position 0, 0. Yeah, I think this is going to work correctly. But we are not going in the right order. We're going backwards. We should go backwards. So we're going to say box X equals, copy X count, paste it, -1. So we start from the count -1. As long as we are higher or equals to 0, and then we go down by 1 every step. Okay, now it goes backwards. So get cell from position, transform, set as first sibling. And this could possibly work. So now all we gotta do is we gotta scramble cells, and we need to tell scramble cells right here to update the UI at the end. So copy this, paste it here, save. Alright, now we're gonna check if this is actually working. So we're gonna hit play, and then we're gonna hit space. Uh-oh. 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 Do you know what happened?
No.
What we're having is called an infinite loop. So there's a while loop that's never been exited. We made a mistake. And we need to reopen the project because it all crashed. Okay, So save. Actually, this is already saved. So let's see here. In scramble cell, this is the culprit for sure. So as long as the list of unscrambled cells.count is higher than 0, if we should be removing at. So what's the issue here? Random position maybe? Huh. I don't know. Let me see what I had done.
Maybe it's that Y loop that you're talking about.
Random position coordinates. This is all correct. So we add a new vector that should be correct. Yeah, right there. Box X, box Y. Then we remove it from all of the current. Then oh, I see. I built another randomizer in here. I don't even know if I need it though. That doesn't seem to be necessary. So let's see here. We move the box of the unscrambled cell, then we add it. Yeah, there's no difference, and then we remove it. Yeah, this is exactly the same. Changes nothing. This is different though, which is interesting. Yeah, it's just a little longer. Actually, that's more efficient. So we are going to do that. So what we're going to do is we're going to give it a value first, and then we're going to loop just this little bit over here to make sure we find a valid random position as opposed to doing this. So we're going to do that a bit differently. Okay. Cut these. Paste them here. Change this to while. So type while. Now copy all of this, paste it here, save. Actually, this should be fine, I think. Yeah, this should be fine. Save. Let's see why any of this could be happening. Let's see if we pass this time, because I may have forgotten something. The two pieces of code look identical. Okay, so this hasn't worked at all. For some reason, it hasn't scrambled. Oh, wait a moment. While random position is save. I think that was the error. While random position is the correct position, then keep on giving us a random one. Got it. Let's try now. Okay. Now they're all scrambled. Now let's check if they're scrambled correctly. All right. So let's identify me one of these. So this one, for example, where should it go?
Here.
Here. So what coordinate should it have?
0, 0.
What coordinate does it have? On the X, what number?
It has 0.
Really?
No,
0 on the X? 1?
No, it has 5, I think.
0, 1, 2, 3, 4, 5. That's outside the world. Why are you throwing out random numbers, Lilith? It's not that difficult. 0, 1, 2, 3. Yay. It's 3. What about Y?
0.
Yes, 3, 0. So 3, 0 should be its current position, and 0, 0 should be its correct position. So 3, 0 would be in the bottom row, and it would be here. Is it bottom row or top row? Bottom row. So it should be here. Yep. Okay, so we selected it. And look, current box position 3, 0, correct box position 0, 0. That looks correct. What about this one? This one here. Right? So this one currently has what coordinates? On the X?
The X has 3.
Really? 0, 1, 2, 3. I asked you for this one. What's the x of this one?
Because its real position will be here, and that position is 3.
Fine, but what its current coordinate is? What is its current coordinate on the x? Hello?
Thinking.
Okay. Is there very much to think about? What column is it in? Count the columns.
1, 2, 3, 4.
Just stop. That's it. These are 4 columns. That's it. And you need to start counting from 0. So what x is this? 0, 1, 2. Winning 2. What about the y? Now you need to count the rows. Y.
1, 2, 3, 4.
0. You always start counting from 0. 0, 1, 3. 2, 3, sorry. 0, 1, 2, 3. So, repeat to me the coordinates it's at right now. X is?
X is... We just did it. I know that y is 3, and x is...
You can see it, Lilith, unless you're blind. You need to count the columns.
0, 1, 2.
Perfect. X is 2. And the y is?
3.
And instead it should be where?
It should be here.
So, what should its coordinates be?
It should be x on 4, and
x on 3.
Should be...
Remember, you start counting from 0.
Yeah, 0, 1, 2, 3.
Yeah.
And now the y should be on 1.
Or, also known as 0.
Or 0. Oh yeah, I start from 0, so 0.
So, this cell should be correct position 3, 0. There it is. And current position 2, 3. There it is. That's good. So let's hit space a couple more times and see if the randomization always works. Uh-oh. 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 It doesn't work sometimes.
And so you can only press it a few times.
That's not the point. It means that sometimes that loop cannot resolve itself. So I made a calculation mistake even before. I just never noticed that I did. Okay? So there is a point at which one of these whiles gets stuck. And I think it's because it cannot find any available position other than the correct one. But I don't understand. So if that's the case, right? If that's the case, then it must mean that the last one is the only position available. Is this even possible? Let's do a quick simulation. I need to think this through. So let's say A needs to go anywhere other than A. Suppose it goes here. So we're going to put NA, that's for new A. Then we go with B. B needs to go anywhere other than where it is. And B. C and C. I'm just D and D. Doesn't really matter. E and E. F and F. G and G. H and H. I and I. J and J. K and K. L and L. So I'm deliberately leaving that row alone. L, M, and M, N, and N, O, and O, P, and P. I'm not sure I can see any circumstance. I cannot see any circumstance where this would get stuck. I cannot imagine it. So as long as the unscrambled cells continues, so the only problem must be here. Yeah, this is where it gets stuck. So while random position, alright, here's what we're gonna do. Create an int, which you're gonna call count. Count. Yeah. Now here you're gonna say, right here you're gonna say count equals 0. Semicolon. With each step, copy, paste, plus plus. We're gonna add a count. And here you're gonna say or count higher than 1000. Save. Here you go. If count higher than 1000, save. Let me type here. This is gonna be slower. Debug.log. It's gonna be count exceeded limit, and then I'm gonna add random position plus list of unscrambled cells 0 dot correct box position. Alright. Now that should fix the error, but it should give us the debug log. So I'm going to keep an eye on this. Nothing. Oh, hello. It immediately got stuck. And that debug log did not trigger. That's odd. I gave it a limit of 1000. And then it should continue. What have I done that's wrong? I've done some thinking wrong here. Let's see. So it's getting stuck here then, or here, but the count is going up, so... Oh, I'm a potato. Or count is lower or equal to... Oh, there you go, there's your answer. I've done that logic wrong. So I was saying, as even if the count goes higher. Okay, there you go. Count exceeded limit. Count exceeded limit. So it's exceeding the limit for all of them? No, not for all of them. Actually, yes, for all of them. That is so strange. Let me see one more time. Count exceeded limit. And it's for all of them again. Okay. I'm a fool sometimes. I've got the logic wrong again. Let's try this one more time. Let's not maximize and play here. Okay. So it didn't. Boom. Okay, we got it one, and that was the last one. So the last one found itself with the only available position being the last one. How is that possible? Okay, let's clear this. I suspect it's always going to be the last one in extremely rare circumstances, but I don't understand how it's possible. We need to examine... Boom. Okay, perfect. Then we need to examine every one of them and what happened to it. So this is the top left one here. So it's got correct box position 1, 3. I trust the correct box positions, I don't even care. But it's 0 and 3, and that's fine. 1 and 3, 2 and 3, 3 and 3. That's already correct. 0, 2, 1, 2, 2, 2, 3, 2. 0, 1, 1, 1.
Yeah, but these shouldn't be together, right? Shouldn't they be in a different place?
What? No, that's fine. That doesn't matter.
Oh, okay.
3, 1, 0, 0, 1, 0, 2, 0, 3, 0. So this is all working correctly. Right? This is all working correctly, with exception that I don't understand how it's possible that something swaps in such a way that everything swaps in such a way that the last, like, how is it possible? Because the second to last one should need a position that isn't itself. I'm really baffled. Position that isn't itself. How would it be possible that, okay, 1 and 1, 1 and 1, 1 and 1, 1 and 1. And how do I get that now? I need to leave this untouched. So you go here. Right, so this one isn't available anymore. This and this. You can either go there if you go, but you can't go there, that's forbidden. So this one's taken too. That leaves this. For this one, all right. This one can go here. Okay, and that leaves the last one with no place to go other than itself. I think I understand now. Look, so these last steps, I'm going to draw them again so you understand. I've made it so that all of these exchange each other, okay, in our random calculation. So all of these cells are already taken. We don't have to worry about them. Now you'll find yourself with the last row to worry about. So take this cell over here. I'm going to put a dot over here. And I'm going to say, I'm going to move you to here, okay? So this cell becomes taken. Understand? Now this cell, I'm going to say, I'm going to move you over here. So this cell becomes taken. So this cell still needs to be moved. I'm going to move it over here, which is legal. So this cell is now taken. Look at what happens. This one needs to be moved, and the only position it's got is itself. Okay? So this can always happen with the last cell. This way. Therefore, we need to make a system that stops this from occurring. Okay, now let's see how we're gonna do this. Random position, list available positions, etc. So we're gonna do this. We're gonna say if list of available positions dot count is higher than 1, so we have more than one available position. Just do this thing. We can delete this safety measure, by the way. We don't need it. Okay. Random position is, and we'll do it, etc. But if it's only 1, let's check, right? If list available position 0, because it's the only one, is the same as the only unscrambled box correct position. What does this mean? This means we've got that situation that we've seen, that extremely rare situation. So what we're going to do in this situation is we are going to tell it, actually, take the spot of another cell, right, that has already been scrambled. Any other cell would do. Okay?
Okay.
So we're gonna pick a random scrambled cells. So we're gonna say random position equals list scrambled cells, random range between 0 and but we need to be we need to be careful. We can't just do that because we need to make sure. No, wait. We know it's not going to be the correct position. It's fine. Yes. So we can pick one of the random cells. Okay. Dot current box position. Oh, I've added an extra bracket here because I'm a potato. So random position is going to be the position, the current position of a randomly moved cell, whichever one. And I'm going to say, but I need to store that cell, don't I? Or this, no, yes, I do. Okay. So here I'm going to build a cell, safety cell equals this thing. Here's my safety cell. Then I'm going to say the random position is going to be the safety cell. I don't even need the random position anymore. Oh yes, I do, because I need to feed it over here. So random position equals safety cell current box position, and then safety cell dot move cell to the correct position of the last one. No, not list of unscrambled cells. Correct box position. So I've moved the safety cell. I've stored the random position. And there we go. Now it's unhappy here because it doesn't know it all the time. So here we're just going to say new vector to int -1 and -1. Now it's going to stop being unhappy. So let's check this again. So as long as we have more than one available positions, we do our normal calculation, okay?
Okay.
If then we only have one available position, we go in here. Here we're going to check if the only available position we have is the same as the correct position of the only unscrambled box that we have. If this is true, right, then we're going to say, we're going to create a new cell. Well, not create it, but we're going to take a new cell and save a random cell of the ones that have already been scrambled, whichever one, it doesn't matter. Okay? We're going to move that one to our save position. Well, we're going to save its current position of this safety cell. And then we're going to move the safety cell to our position of this only unscrambled tile. And then we are going to give, basically we're going to swap them. That's what we do, right? So if we get ourselves in this situation again, right, where this cell can only go here, right, we're going to take any of them. Let's suppose this one. And we're going to tell this one, hey man, you go over here and leave this one open for this one. Does that make sense? Okay, now let's create a test, just a debug log right here to check if this has happened. Had to swap the last one. Okay, and now let's see if it's going to occur. It should. And this should fix all the problems. Null reference. Okay, that's already a problem. Okay. Update UI, I understand that. Scramble cells. Well, this is not going to tell us much. So it must mean get cell from position. We must have received a null here. So let's request position. Have we got any other problems that I failed to pay attention to? Let's see. Let's hope so. Right? We want to kill all of these bugs in advance. Okay. So this is 2, 3. Okay. So this is just a silly error I've just introduced, but you see the last one would be 3, 3. Debug log position 3, 3. Well, actually, no. Wait. It fails. No, it doesn't fail. So the last one was 2, 3, and 2, 3 fails. I'm confused. Get cells from position. It fails on 2, 3. Does it fail every time on 2, 3? Yeah. No. Wait a moment. 0, 3. What in the world? 3, 0, 2, 0, 1, 0. Okay. 3, 1. Okay. So yeah, because we go backwards, and then 3, 2, 2, 3, 1, 3, 0, 3. So 0, 3 is not found. What the heck? What's happening? Let's check them all. Oh, hello. Oh. All of them are... all of these 5 are here. 3, 3, 2, 3. Excuse me, current box. Okay, we got 2, 3, 2s right here. Right, so we've done something incorrect, which is a bit strange. Let's see. So here we made a mistake of some sort. Safety cell, move cell. What did I get wrong? I guess I didn't have to swap the last one. Oh, I see. We need to check this. So it would be end never mind. As long as it's higher than, right? So I understand what's happening. The problem is if it's not higher than, it goes here, but it could still be valid. Because if that's not the case, then random position equals list available positions 0. So we just broke every other case, but that's okay. That should fix it now. You probably have no idea what's happening, but that's okay. All right, no errors, perfect. So what's this debug log? No, we don't need this debug log, but the debug log I do want is had to swap the last one. That's the one I want.
But what are these?
Those are debug logs. I'll turn them off now. Had to swap that was the previous one. I got it again. All right, so the last one is this, right? And it had to be swapped. So it's currently right here. That's the last one. And it's in current position 3, 0. Its official one was supposed to be 3, 3. So it looks correct. Everything looks fine, but it had to swap it. So it moved it. We got that rare case. Cool. I think we fixed every one of them. Let's keep them hitting space. Every now and then it will tell us how to swap the last one. Looks pretty good to me, no? Mm-hmm. Okay, so we're basically done for today, but we are gonna do one more thing, and I'm gonna show you what we're gonna do. And we're gonna use a little cheat to fix it. But there's a small problem. So now, can you see there's a line here in the middle?
Mm-hmm.
It's kind of hard to see, but look, right here. Do you see this line? This black, darker line right here? Yeah. We get errors like these on the picture sometimes. Ah, there he was. It's kind of hard to see. It should happen on the edges, though. That doesn't always happen. Let me make it non-maximized and you'll see it much more. There it is. Look at it right here in the middle. Can you see it?
Yeah.
The reason why that's happening is, well, there's two. One of them is our canvas should be set to pixel perfect, which it is. And the other reason is our texture has a small problem. So what we're gonna do is we're gonna tell our texture not to clamp. Clamp means that the texture essentially, once it's been drawn fully, if you draw past it, it's going to keep the last pixel and not allow you to have any other colors. What we're gonna do is we're gonna change it to wrap. So as soon as you go past the end, it starts from the beginning again. This will give us one extra pixel of allowance. So to allowance. One extra allowance of a pixel. So here, when we go to split sprite, oh look, daddy fix. I had already noticed this. So we're gonna change the texture wrap mode to repeat. That allows it to go past. And this should remove all of those. Let's see if it does. Oh, never mind, they're still here. Yeah, they're still here. There you go, see it?
Yep.
It doesn't appear now. Just like it didn't appear before. Yeah, I don't know if this makes a huge difference. Yeah, it might have to do with the fact that we are changing the
code.
No, we're moving the UI sort of thing and everything. Okay, well, technically we're already past the hour, but we are so close to being done. Well, not really, actually. We still need to do all of the button selection and everything. We're gonna leave that for next time. Okay?
Okay.
Thanks everyone for watching. We'll see you again next time. Bye!
Bye.